The captured North American P-51 Mustang sat in the morning sun at Rechlin-Lärz airfield, its American star insignias hastily painted over with German crosses. Oberleutnant Hans-Werner Lerche circled the aircraft slowly, his trained eye taking in every detail of the fighter that had been terrorizing Luftwaffe formations for months. It was May 1944, and this particular Mustang, serial number 436963, had been forced down near Osnabrück after taking damage from flak. The German recovery team had found it remarkably intact, its American pilot already captured and on his way to a POW camp. Now, Lerche, one of the Luftwaffe's most experienced test pilots, had orders that seemed almost absurd in their simplicity. Fly this American fighter and tell us why we cannot stop it. He ran his hand along the wing's leading edge, feeling the smooth laminar flow surface that seemed almost impossibly refined. In his decade of testing German fighters, from the early Messerschmitt Bf-109 prototypes to the revolutionary Me-262 jet, he had never encountered an aircraft that radiated such confidence just sitting motionless on the tarmac. The Americans called it Mustang, a name that suggested wild, untamed power. Standing beside it now, Lerche understood why. This was not just another fighter aircraft. This was something that would force him to reconsider everything he thought he knew about air combat. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The story of how the Luftwaffe came to possess operational American fighters is itself a testament to the brutal arithmetic of the air war over Europe. By mid-1944, the skies over Germany had become a hunting ground where thousands of aircraft clashed daily. Inevitable mathematical certainty dictated that some American fighters would be forced down on German soil, their pilots killed, captured, or occasionally escaped. The Luftwaffe had established a systematic program for recovering and evaluating enemy aircraft, operated primarily out of Rechlin, the Luftwaffe's primary testing facility located roughly 60 miles north of Berlin. The Erprobungsstelle Rechlin, or Rechlin Test Center, had been evaluating captured Allied aircraft since 1940, starting with French fighters after the fall of France, then British Spitfires and Hurricanes after the Battle of Britain. By 1944, the facility had tested dozens of Allied types, from the lumbering Boeing B-17 Flying Fortress to the nimble Soviet Yak fighters captured on the Eastern Front. Each captured aircraft was meticulously examined, test-flown, and analyzed to identify weaknesses that Luftwaffe pilots could exploit. The intelligence gathered was compiled into detailed tactical bulletins distributed to operational fighter units. These reports included everything from the enemy aircraft's performance envelope to specific vulnerabilities in armor protection or blind spots in defensive armament. But the P-51 Mustang presented a unique challenge. Unlike earlier American fighters such as the Republic P-47 Thunderbolt, which German pilots had learned to counter through specific tactical approaches, the Mustang seemed to possess no obvious weaknesses. It was fast but also maneuverable. It had range but also combat performance. It climbed well and dove well. It could fight at high altitude or low altitude with equal effectiveness. Early combat reports from Luftwaffe fighter units were filled with frustrated assessments that all essentially said the same thing. The Mustang can do everything, and we cannot find a consistent way to defeat it. The Mustang that Lerche was preparing to fly in May 1944 was a P-51B model, powered by the Packard-built Merlin V1653 engine, producing 1,490 horsepower. The aircraft had been forced down on April 28, 1944, by a combination of flak damage and engine trouble. Its pilot, First Lieutenant James Howard of the 357th Fighter Group, had managed a wheels-up landing in a field near Osnabrück before being captured by Wehrmacht soldiers. The Mustang had suffered relatively minor damage: a cracked propeller, some torn aluminum skin on the fuselage, and damage to the radiator housing. German ground crews, working with surprising speed and competence, had repaired the aircraft using a combination of salvaged American parts from other wrecks and improvised German components. Within 2 weeks, the fighter was flyable again, though German mechanics noted in their reports that the manufacturing quality of American components was extraordinarily high. One mechanic wrote in his technical assessment that every bolt, rivet, and structural element was machined to tolerances that exceeded German military standards despite being mass-produced. The implication was sobering. America was building fighters of exceptional quality at a rate that Germany, even with its vaunted engineering precision, could not match. By early May, the captured Mustang was ready for flight testing, and Hans-Werner Lerche was the obvious choice as test pilot. At 31 years old, Lerche was one of the Luftwaffe's most experienced and skilled test pilots, with thousands of hours in over 70 different aircraft types. He had been testing fighters since 1938 and had personally evaluated most of the Luftwaffe's frontline aircraft before they entered service. More importantly, he had extensive combat experience, having flown operational missions during the Battle of Britain and later on the Eastern Front before being assigned full-time to test duties. This combination of test pilot expertise and combat experience made him uniquely qualified to assess the Mustang not just as an engineering artifact, but as a weapon system that would be used in actual combat. The briefing before the first flight was conducted by Major Theodore Roell, commander of the test pilot section at Rechlin. Roell had assembled a team of engineers, intelligence officers, and experienced combat pilots to observe Lerche's flights and provide analysis. The orders were explicit. Lerche was to thoroughly evaluate the Mustang's flight characteristics, performance envelope, handling qualities, and combat capabilities. He was to identify any weaknesses or limitations that could be exploited by Luftwaffe fighter pilots. Most importantly, he was to determine why this American fighter had proven so difficult to counter in combat. The briefing included detailed technical drawings of the Mustang obtained through intelligence channels, performance specifications based on combat observations, and tactical analyses of engagements between Mustangs and German fighters. A document caught Lerche's attention. A combat report from Hauptmann Heinz Baer of Jagdgeschwader 1, one of the Luftwaffe's highest-scoring aces with over 200 victories. Baer had written after an engagement with Mustangs in March 1944. These American fighters are unlike anything we have encountered. They possess the speed of the Focke-Wulf 190, the maneuverability approaching that of our 109, and range we cannot match. Most troubling is that they seem to have no altitude where they are uncomfortable. They fight equally well at 20,000 feet or on the deck. I shot down one Mustang only because I caught it by complete surprise. In any equal engagement, the advantage is with the American. For a pilot of Baer's caliber and experience to express such grudging respect for an enemy aircraft was highly unusual and deeply concerning. As Lerche climbed into the cockpit of the captured Mustang, he immediately noticed differences from German fighter design philosophy. The cockpit was spacious by German standards, offering excellent visibility in all directions. The canopy, though not yet the bubble type that would appear on later D models, still provided far better visibility than the heavily framed canopies of the Bf 109 or 4190. The instrument panel was logically laid out, with primary flight instruments clustered centrally and engine instruments grouped to the right. Everything was labelled in English, of course, but Lerche had studied the cockpit layout extensively and had American technical manuals translated into German for reference. The seat was comfortable and adjustable, the control stick fell naturally to hand, and the rudder pedals were positioned ergonomically. German fighters, designed with an emphasis on performance over pilot comfort, typically featured cramped cockpits with poor visibility and awkward control placement. The Mustang felt like it had been designed with the understanding that a comfortable pilot is a more effective pilot, a philosophy that seemed distinctly American in its pragmatism. Lerche methodically worked through the pre-flight checks, following the translated American procedures. The Packard Merlin engine started easily, settling into a deep, powerful rumble that resonated through the airframe. The sound was distinctive, different from the high-pitched scream of a Daimler-Benz 605 or the throaty roar of a BMW 801. It was a sound that Luftwaffe pilots had learned to fear, the sound that announced the presence of fighters that could chase them anywhere over Germany. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now, back to the story. Taxiing the Mustang proved straightforward, the tailwheel steering responsive, and the forward visibility adequate despite the aircraft's tail-down attitude. German observers noted that Lerche seemed completely at ease of the unfamiliar aircraft, his years of test flying experience evident in his smooth, confident handling. At the end of the runway, Lerche performed his final checks, then advanced the throttle smoothly forward. The Packard Merlin responded instantly, the propeller biting into the air with authority as the fighter began rolling down the runway. Acceleration was brisk but not brutal, the Mustang building speed steadily as Lerche monitored the instruments. At approximately 90 miles per hour indicated airspeed, he eased back on the stick and the Mustang lifted off smoothly, climbing away from Rechlin with an ease that immediately impressed the watching German observers. The initial climb revealed the first of many surprises. The Mustang climbed at a higher angle than Lerche had expected. The rate of climb showing on the vertical speed indicator as nearly 3,000 feet per minute at combat power. This matched the performance of the Bf-109 Gustav in initial climb, despite the Mustang being significantly heavier and carrying far more fuel. As altitude increased, the Merlin engine's two-stage supercharger began demonstrating its superiority over German engine designs. German fighter engines, whether the Daimler-Benz 605 in the Bf-109 or the BMW 801 in the FW-190, used single-stage superchargers that maintained power reasonably well to about 20,000 feet, but then experienced significant power loss at higher altitudes. The Merlin's two-stage, two-speed supercharger system maintained power much more effectively, actually increasing power output at certain altitude bands as the second stage engaged. Lerche noticed this immediately as he climbed through 20,000 feet. Rather than feeling the engine begin to labor as it would in a German fighter, the Merlin seemed to pull even stronger. At 25,000 feet, Lerche began the systematic evaluation that was the purpose of this flight. He started with basic handling checks, gentle turns left and right, climbs and descents at various power settings, acceleration and deceleration runs. The Mustang responded to all control inputs with a harmony that was immediately apparent. Aileron response was crisp without being sensitive. Elevator control was well balanced, and rudder effectiveness was good even at high altitude, where many fighters became sluggish. The aircraft felt stable yet responsive, powerful yet manageable. It was, Lerche would later write in his report, like flying an aircraft that had been refined through years of development rather than rushed into production. Every control input produced exactly the response expected, with no unpleasant surprises or handling quirks. German fighters, for all their performance advantages, often had significant handling peculiarities that required careful pilot technique. The Bf-109 was notoriously difficult to land, with a narrow-track landing gear that made ground handling treacherous. The full 190 had excellent roll rate but heavy elevator forces at high speed. The Me-2 62 jet had asymmetric thrust problems and dangerous stall characteristics. The Mustang seemed to have none of these issues. It simply did what the pilot asked it to do, smoothly and predictably. This quality, Lerche realized, was itself a significant tactical advantage. A pilot who could trust his aircraft implicitly could focus entirely on fighting the enemy rather than managing aircraft handling issues. The high-speed handling evaluation proved even more impressive. Lerche pushed the throttle to maximum continuous power and nosed over into a gentle dive, allowing the Mustang to accelerate to maximum speed. The airspeed indicator wound up steadily. 300 miles per hour, 350, 400, 420. At 430 miles per hour indicated, the Mustang was still accelerating smoothly, with no buffeting, no control heaviness, no tendency toward an instability. Lerche had flown the FW-190 to comparable speeds and knew that at this velocity, the Focke-Wulf's ailerons became extremely heavy, requiring both hands on the stick to execute a roll. The Mustang's ailerons remained light and responsive even at maximum speed, allowing rapid roll changes that would be crucial in combat. The laminar flow wing design, which minimized drag by maintaining smooth airflow over a greater percentage of the wing surface, was clearly working as intended. American engineers had achieved something that German designers had attempted but never fully realized. A wing that maintained efficiency across the entire speed range, from stall to maximum velocity. The combat implications were obvious. A fighter that could maneuver effectively at high speed possessed an enormous advantage in the diving attacks and high-speed pursuit situations that characterized modern air combat. German fighters generally had to slow down to maneuver effectively. The Mustang could maneuver at speeds where German fighters could barely maintain control. Lerche next evaluated the Mustang's turning performance, the classic measure of fighter maneuverability. Rolling into a hard left turn at combat power, he pulled back on the stick to load the aircraft to 4 Gs, then 5, then 6. The Mustang responded beautifully, carving a tight circle in the sky with none of the buffeting or tendency towards stall that would affect most fighters at these load factors. The stall warning came gradually and gently, giving the pilot plenty of time to recognize the onset and reduce back pressure before reaching the actual stall. This progressive stall characteristic was another significant advantage over German fighters, which often exhibited abrupt, violent stalls that could prove fatal in combat. Lerche reversed the turn, rolling right and pulling hard again. The roll rate was excellent, comparable to the P-190, which had the best roll performance of any German fighter. But unlike the Focke-Wulf, the Mustang maintained this roll performance across the entire speed range. A Fu-190 could outroll a Mustang at low speed, but the Mustang could outroll a Fu-190 at high speed. This meant that the Mustang pilot could fight effectively regardless of speed, while the German pilot had to maneuver to his aircraft's strengths and away from its weaknesses. After 45 minutes of increasingly aggressive maneuvering, Lerche had reached a preliminary conclusion that he found deeply troubling. The Mustang was simply a better all-around fighter than anything in the Luftwaffe inventory. It wasn't dramatically superior in any single category, but it was very good in every category, and it had no significant weaknesses to exploit. A Bf-109 could match or slightly exceed the Mustang's climb rate and high-altitude performance. A Fu-190 could match the Mustang's roll rate and low-altitude speed, but no German fighter could match the Mustang's combination of capabilities across the entire performance envelope. The landing proved as straightforward as everything else about the Mustang. Lerche entered the traffic pattern at Rechlin, configured the aircraft with landing gear and flaps extended, and made a smooth approach to touchdown. The landing gear was sturdy and well damped, absorbing the landing loads without bouncing or swerving. Forward visibility on the ground was adequate, and the tailwheel steering made taxiing back to the test facility simple. As Lerche shut down the engine and climbed out of the cockpit, he was immediately surrounded by the waiting team of engineers, intelligence officers, and pilots, all eager to hear his assessment. Major Roel spoke first. "Well, Lerche, what do you think?" Lerche was silent for a long moment, choosing his words carefully. What he was about to say would not be welcome news, but as a test pilot, his job was to report facts, not convenient fictions. "Gentlemen," he said finally, "we have a very serious problem. That aircraft is better than anything we have. Not by a huge margin in any single area, but across the board, in every category that matters in combat. It's faster than our 109, more maneuverable than our 190, and it has range we cannot match. Worse, it has no handling vices, no significant weaknesses. An average pilot can fly it to its limits. An excellent pilot can do things with it that would be impossible in our aircraft." The silence that followed was profound. Major Roel looked grim. Several of the intelligence officers exchanged worried glances. One of the combat pilots present, Hauptmann Johannes Steinhoff of Jagdgeschwader 7, asked the critical question. "So how do we fight it?" Lerche considered carefully before answering. "We must avoid equal combat. We need surprise, altitude advantage, numerical superiority. If a 109 or 190 meets a Mustang in equal circumstances, the advantage is with the American. That's not defeatism. That's simple fact based on aircraft performance. The Mustang is simply a better tool for the job. The debriefing that followed Lerche's first flight lasted several hours, with the test pilot providing detailed analysis of every aspect of the Mustang's performance and handling. His written report, filed that evening, was extraordinarily thorough and brutally honest. He praised the Mustang's cockpit layout, visibility, handling qualities, and performance across the board. He noted specific advantages such as the excellent high-speed handling, progressive stall characteristics, and outstanding range. Most significantly, he identified the fundamental design philosophy that made the Mustang so effective. It was optimized for actual combat rather than theoretical performance maximums. German fighters were often designed to achieve specific performance goals, in particular flight regimes. The Bf-109 was optimized for high-altitude interception. The FOW-190 was optimized for low-level attack and hit-and-run tactics. The Mustang was designed to perform well across all altitudes, all speeds, all combat situations. This operational flexibility made it a more practical combat weapon than theoretically superior aircraft that only excelled in specific circumstances. Lerche's report concluded with a recommendation that proved controversial. The Luftwaffe should study the Mustang's design philosophy and incorporate its lessons into future German fighter development. Specifically, he recommended greater emphasis on pilot comfort and visibility, more attention to handling qualities across the entire flight envelope, and less focus on achieving maximum performance at the expense of practical usability. These recommendations were largely ignored by the Luftwaffe High Command, which continued to prioritize theoretical performance maximums over operational practicality. Over the following weeks, Lerche conducted multiple additional flights in the captured Mustang, each time exploring different aspects of its performance and capabilities. He flew mock combat engagements against Bf-109 Gustavs and full 190 Anton 8s, the Luftwaffe's primary frontline fighters. The results were sobering. In simulation after simulation, the Mustang demonstrated its superiority. Against the Bf-109, the Mustang could extend away at any altitude, forcing the German fighter to break off the engagement. If the 109 tried to escape by diving, the Mustang's superior high-speed handling allowed it to follow and close the distance. The 109's only advantage was a marginally better rate of climb at altitudes above 25,000 feet, but this advantage was too small to be tactically decisive. Against the Foch-190, the results were equally one-sided. The Focke-Wulf could match the Mustang's speed at low altitude and could outroll it in the slow-speed regime, but the Mustang's superior power-to-weight ratio gave it better acceleration and sustained turn performance. In a prolonged engagement, the Mustang pilot could eventually force the TEP-W190 into a position of disadvantage through sheer persistence. The mock combat results confirmed what Lerche had concluded after his first flight. In equal circumstances, the Mustang was simply the better aircraft. The only way for German fighters to successfully engage Mustangs was to avoid equal circumstances entirely, instead relying on surprise, numerical superiority, or tactical advantages such as altitude or sun position. Other Luftwaffe test pilots were given opportunities to fly the captured Mustang, and their assessments uniformly confirmed Lerche's conclusions. Oberleutnant Fritz Kelb, another experienced test pilot, flew the Mustang in June 1944 and reported that it was the finest all-around fighter he had ever flown, superior even to the Revolutionary. Me-262 jet in terms of handling qualities and practical usability. The jet was faster, Kelb noted, but it was also far more difficult to fly, had much shorter endurance, and was extremely vulnerable during takeoff and landing. The Mustang, by contrast, was easy to fly, could remain airborne for hours, and could defend itself effectively at any point in the flight. Hauptmann Heinz Baer, the ace who had written the early combat assessment of the Mustang, was given a chance to fly the captured aircraft in July 1944. After his flight, Baer's assessment was characteristically blunt. "Now, I understand why we're losing. This aircraft is what a fighter should be. Everything about it makes sense. Everything works. There are no compromises, no flaws, no tricks needed to fly it well. An average American pilot in this aircraft is more than a match for a good German pilot in a 109 or 190. We need something this good, and we need it in numbers that can make a difference. We have neither. The technical analysis conducted by German engineers at Rechlin revealed insights that were both fascinating and deeply troubling for the Luftwaffe's future prospects. The captured Mustang was systematically disassembled over several weeks, with every component measured, weighed, analyzed, and compared to equivalent German systems. What emerged from this exhaustive examination was a portrait of American industrial and engineering capability that shattered many preconceptions held by German technical experts. The Packard-built Merlin engine was removed from the airframe and subjected to particularly intense scrutiny. German engineers had long respected the Rolls-Royce Merlin as an excellent power plant, but they had assumed that American license production would result in quality compromises. Instead, they discovered that Packard had not merely copied the British design, but had systematically improved it. The American-built engine incorporated tighter manufacturing tolerances, superior metallurgy in critical components, and design refinements that improved reliability and maintainability. Perhaps most remarkable was the production quality. Every component showed evidence of precision machining that exceeded German military standards, yet the engines were being produced at a rate of over 400 per month. One German engineer, Dippel, Ing. Hermann Oesterl, wrote in his analysis report that the engine represented a manufacturing philosophy fundamentally different from German practice. Where German engines were built with careful hand-fitting of components by skilled craftsmen, the Packard Merlin was designed for mass production with interchangeable parts. Every connecting rod was identical within extraordinarily tight tolerances. Every piston was precisely the same weight and dimension. This meant that engines could be assembled rapidly by semi-skilled workers, maintained easily in field conditions, and repaired by simply swapping standardized components. The implications were staggering. America was producing superior engines faster, cheaper, and more consistently than Germany could produce inferior ones. The airframe construction revealed similar advantages. The Mustang's fuselage was a semi-monocoque structure using aluminum alloy frames and stringers covered with flush-riveted aluminum skin. German engineers noted that the skin panels were remarkably smooth, with rivets countersunk perfectly flush with the surface to minimize drag. This level of finish quality across the entire airframe represented manufacturing capability that German plants, even before Allied bombing disrupted production, had struggled to achieve. The flush riveting alone required specialized equipment and highly skilled workers, yet the Americans were applying it to every single Mustang produced. The wing structure was particularly impressive, incorporating the laminar flow airfoil that gave the Mustang its excellent high-speed characteristics. German engineers had experimented with laminar flow wings, but had never successfully brought the technology into mass production due to the extreme precision required in manufacturing. The wing surface had to be perfectly smooth, with no irregularities or protrusions that would disrupt airflow. American factories were achieving this level of precision on wings being produced at a rate of hundreds per month. Oberingenieur Kurt Tank, designer of the Focke-Wulf 190 and one of Germany's most brilliant aircraft engineers, was brought to Rechlin to examine the captured Mustang. His assessment, preserved in Luftwaffe records, was remarkably candid. Tank noted that the Mustang incorporated no revolutionary technologies or unprecedented innovations. Everything about it represented proven, mature engineering, applied with exceptional competence. The genius of the design lay not in any single brilliant insight, but in the systematic optimization of every element to work in harmony. The result was an aircraft that was greater than the sum of its parts, a machine that possessed no significant flaws, because every potential flaw had been identified and engineered away during development. The fuel system received particular attention from German analysts because it was the key to the Mustang's extraordinary range. The internal fuel capacity of 85 gallons in the fuselage tank and 2 wing tanks holding 92 gallons each gave the Mustang 177 gallons of internal fuel. Additionally, the aircraft could carry 2 external drop tanks of either 75 gallons or 108 gallons each, bringing total fuel capacity to as much as 393 gallons. This was nearly double the fuel capacity of a Bf-109 Gustav and 50% more than a Fuev-190 Anton. But fuel capacity alone did not explain the Mustang's range advantage. The Merlin engine's fuel consumption at cruise settings was remarkably low, allowing the Mustang to fly for over 5 hours on internal fuel alone. German fighters, with their less efficient engines and higher cruise fuel consumption, could barely manage 90 minutes of flight time before needing to land and refuel. The tactical implications were profound. Mustang pilots could fly deep into Germany, engage in combat for 30 minutes or more, and still have ample fuel to return to England. Luftwaffe pilots had to carefully manage their fuel from the moment they took off, always aware that prolonged combat might leave them without enough fuel to land safely. This psychological burden affected German pilot performance in subtle but significant ways. A pilot worried about fuel cannot focus entirely on combat. A pilot who knows he has fuel to spare can fight with complete concentration on defeating the enemy. The armament installation was analysed with particular interest. The P-51B model carried 4 Browning 50 caliber machine guns, 2 in each wing, with 400 rounds per gun for a total of 1,600 rounds. German engineers noted that while this firepower was lighter than the typical German fighter armament of 1 20mm or 30mm cannon plus 2 machine guns, the American installation had significant advantages. The 50 caliber machine guns were highly reliable, with jam rates far lower than German weapons. They were harmonized to converge at 300 yards, creating a concentrated cone of fire that was devastatingly effective against both aircraft and ground targets. The ammunition feed systems were beautifully engineered, using link belt feeds that were far less prone to jamming than the German drum or belt systems. Most significantly, the Mustang carried enough ammunition for extended combat. German fighters, with their heavier but lower velocity cannon, typically carried enough ammunition for only a few seconds of sustained firing. The Mustang could fire continuously for over 30 seconds, giving the pilot multiple engagement opportunities in a single mission. Luftwaffe combat pilots who reviewed the armament analysis noted that this ammunition capacity represented a significant tactical advantage. A German pilot who missed with his initial attack might not have enough ammunition remaining for a second pass. A Mustang pilot could make multiple attacks, learning from each engagement and adjusting his aim. The control system was examined with particular interest by Luftwaffe engineers who had struggled with high-speed handling problems in German fighters. The Mustang used hydraulically boosted ailerons that maintained light control forces even at maximum speed. This was a relatively simple system, using aerodynamic balance tabs that effectively reduced the force required to move the control surfaces. German fighters had experimented with similar systems, but had generally not implemented them due to added complexity and weight. The Mustang demonstrated that the performance advantages of power-boosted controls far outweighed the minor weight penalty. More subtly, the Mustang's control harmony was achieved through careful attention to the relationship between different control surfaces. The elevator, ailerons, and rudder were all designed to work together naturally, requiring minimal pilot coordination. In German fighters, particularly the Bf-109, pilots had to use substantial rudder input during maneuvers to counteract adverse yaw from aileron deflection. The Mustang's controls were so well harmonized that rudder inputs were minimal, allowing pilots to focus on the tactical situation rather than on managing aircraft behavior. This quality made the Mustang easier to fly in combat and reduced pilot workload significantly. An exhausted pilot at the end of a long mission could still fly the Mustang effectively. A similarly exhausted German pilot in a Bf-109 had to maintain constant vigilance to avoid dangerous departures from control flight. Hans-Werner Lerche conducted additional specialized tests throughout June and July 1944, exploring aspects of the Mustang's performance that would not normally be examined in initial flight testing. One series of flights focused on the aircraft's behavior at extreme altitudes. Lerche flew the Mustang to 38,000 feet, higher than most combat engagements occurred, to determine how it performed in the thin air of the stratosphere. The results were impressive. The Mustang maintained controllability and reasonable performance, even at altitudes where most German fighters became barely manageable. The Merlin engine's supercharging system continued to deliver adequate power, and the wing's laminar flow design maintained lift effectively despite the low air density. This high-altitude capability gave the Mustang another tactical advantage. It could climb above German fighters to gain the dominant position, then dive down to attack with enormous speed. Advantage. Another series of test flights examined the Mustang's suitability for ground attack missions. Lerche flew the aircraft at low altitude, practicing the kind of strafing runs that Allied fighters were increasingly conducting against German ground targets. The Mustang proved excellent for this role, with stable gun platforms, adequate armor protection for the pilot, and sufficient structural strength to withstand the stress of high-speed, low-altitude maneuvering. The long range meant that Mustangs could penetrate deep into Germany, attack targets of opportunity, and return to base. Luftwaffe fighters attempting similar missions had to operate close to their bases due to limited fuel capacity, reducing their effectiveness. The psychological impact of flying the captured Mustang affected every Luftwaffe pilot who experienced it. These were men who had been told since the beginning of the war that German engineering was superior, that German aircraft were the finest in the world, that the Luftwaffe's dominance was built on technological advantage as much as pilot skill. Flying the Mustang shattered these comfortable assumptions. Oberleutnant Hans-Werner Lerche, who flew the captured aircraft in August 1944, wrote in his diary that evening about the experience with unusual emotional intensity. He described feeling a sense of betrayal, as if the German leadership had been lying to Luftwaffe pilots about their equipment's quality. The Mustang was simply better, he wrote, and every pilot who flew it knew immediately that they had been flying inferior aircraft while being told they had the best. This realization was profoundly demoralizing. It suggested that German losses were not due to poor tactics or inadequate training or pilot cowardice, but to structural disadvantage that no amount of skill or courage could overcome. The implications extended beyond individual pilot morale to strategic calculations. If Germany was building inferior aircraft despite its vaunted engineering prowess, what did that say about the war's likely outcome? The testing program at Rechlin continued through the summer and into autumn of 1944, with the captured Mustang flying dozens of evaluation missions. Other captured P-51 models arrived at the facility, including a later P-51D with the bubble canopy that provided even better visibility than the earlier models. Each aircraft was thoroughly tested, with results consistently confirming that the Mustang was comprehensively superior to equivalent German fighters. The test data was compiled into detailed reports distributed to Luftwaffe operational units, providing tactical recommendations for combat against Mustangs. These recommendations essentially advised German pilots to avoid combat with Mustangs unless they possessed overwhelming tactical advantage. Engage only with altitude advantage. Attack from the sun. Use numerical superiority. Break off combat immediately if the situation becomes equal or disadvantageous. These were the tactics of a force that knew it was technologically outmatched, tactics that emphasized survival over victory. For Luftwaffe pilots who remembered the aggressive offensive tactics of the early war years, this defensive posture was psychologically devastating. They had gone from hunters to hunted, from predators to prey. The captured Mustang testing program also included mock combat scenarios against Germany's newest and theoretically most advanced fighters. In September 1944, Lerche flew comparative flights between the Mustang and the Focke-Wulf Ta-152H, an advanced high-altitude fighter that was supposed to counter Allied bomber escorts. The Ta-152 had excellent performance above 30,000 feet, with a top speed exceeding 450 miles per hour and outstanding climb rate at altitude. In theory, it should have been superior to the Mustang in the high-altitude regime where bomber interceptions occurred. In practice, the comparison revealed the Ta-152's limitations. While it could match or slightly exceed the Mustang's performance at extreme altitude, it was significantly inferior at medium and low altitudes. More critically, the Ta-152 was extraordinarily difficult to fly, with heavy controls, poor visibility, and handling characteristics that required constant pilot attention. The Mustang was easier to fly, more forgiving of pilot error, and effective across a much broader altitude range. A TAR-152 pilot had to maneuver to maintain altitude advantage. A Mustang pilot could fight effectively wherever combat occurred. Additionally, the TAR-152 was produced in tiny numbers due to complex manufacturing requirements and disruption of German industry by Allied bombing. Even if it had been clearly superior to the Mustang, there were not enough of them to matter strategically. Similar comparisons were conducted against the Messerschmitt Me-262 jet fighter, which began entering service in limited numbers in autumn 1944. The Me-262 was dramatically faster than the Mustang, with a maximum speed exceeding 540 miles per hour compared to the Mustang's 437. This speed advantage should have made the jet nearly invulnerable to piston-engine fighters. However, the test flights revealed significant limitations that reduced the jet's practical effectiveness. The Me-262 had very limited endurance, able to remain airborne for less than an hour, including takeoff, combat, and landing reserves. The engines were temperamental and required careful handling to avoid flameouts or explosions. The aircraft was extremely vulnerable during takeoff and landing when it could not use its speed advantage. Most critically, the Me-262 had relatively poor, low-speed handling and turning performance. A Mustang could not catch a jet in level, flight or a dive, but in a turning fight at moderate speeds, the Mustang could outmaneuver the jet decisively. Luftwaffe jet pilots learned that they had to use pure hit and run tactics, making a single high-speed pass and then running away before Mustang escorts could react. This limited their effectiveness significantly. The testing program demonstrated that while the Me-262 possessed theoretical advantages, the Mustang remained a more practical combat weapon for the conditions of the air war in 1944 and 1945. By late 1944, the captured Mustang testing program at Rechlin had achieved its objectives, though the results were not what Luftwaffe leadership wanted to hear. The comprehensive evaluation had confirmed that the P-51 Mustang was superior to all German piston-engine fighters in overall combat effectiveness. It was not dramatically better in any single performance category, but it was consistently good across all categories, and it had no significant exploitable weaknesses. The testing had identified some minor tactical advantages that German pilots could exploit in specific circumstances, but these were small consolations that could not change the fundamental balance of power. The American fighter was simply a better tool for the job of air combat, and it was being produced in numbers that Germany could not match. The psychological impact of this realization cannot be overstated. The Luftwaffe had entered the war confident in its technological superiority and pilot skill. By late 1944, both advantages had evaporated. American pilots were now as well trained as German pilots, often with more flight hours and better preparation. American fighters were superior to German designs in practical combat effectiveness. American industrial production vastly exceeded German capacity, meaning that numerical superiority favored the Allies. The Luftwaffe faced enemies who were more numerous, better equipped, and equally skilled. This was not a situation that bravery or tactical innovation could overcome. The final reports from the Rechlin testing program were distributed throughout the Luftwaffe command structure in December 1944. These documents, preserved in archives after the war, make for sobering reading. They represent the institutional admission that Germany had lost technological superiority in fighter aircraft, perhaps irretrievably. Major Rovale wrote in his summary that the Mustang represented a level of design maturity and manufacturing excellence that Germany could not match given current circumstances. The combination of Allied bombing disruption, fuel shortages, and loss of experienced engineers and skilled workers meant that even if Germany designed fighters equal to the Mustang, they could not be produced in sufficient numbers to matter. The war in the air had become a war of attrition, and attrition wars are won by the side with greater resources. America possessed those resources in overwhelming abundance. Every evaluation of the captured Mustang reinforced this uncomfortable truth. The aircraft sitting on the ramp at Rechlin was not just a fighter plane. It was a symbol of American industrial might, technological sophistication, and systematic engineering excellence applied to the problem of winning the war. German pilots who flew it understood immediately that they were fighting an enemy who had surpassed them, not through luck or temporary advantage, but through fundamental superiority in industrial organization and engineering execution. The story of Luftwaffe pilots flying the captured Mustang is ultimately a story about the collision between myth and reality. German military culture had been built on the myth of German technological and tactical superiority. The belief that German engineering and German fighting spirit were inherently superior to those of other nations. The Mustang shattered this myth completely. It proved that American engineers could design better aircraft, American factories could build them in greater numbers, and American pilots could fly them to devastating effect. The Luftwaffe pilots who flew the captured Mustang at Rechlin were forced to confront this reality directly, to acknowledge that everything they had been told about German superiority was propaganda rather than fact. This psychological blow was in some ways more devastating than the physical destruction inflicted by Mustangs in combat. It destroyed the faith that had sustained German fighter pilots through years of increasingly desperate combat. When Hans-Werner Lerche climbed out of the Mustang's cockpit after his first flight, he knew something that would spread throughout the Luftwaffe over the following months. Germany had been building inferior fighters while claiming superiority, and the price of that self-deception would be paid in the lives of young pilots sent into combat with inadequate equipment. The captured Mustang was more than just an aircraft to be tested and analyzed. It was evidence of a failure so profound that no amount of courage or skill could compensate for it. The intelligence value of the captured Mustang extended far beyond simple performance evaluation. Luftwaffe technical intelligence officers recognized that understanding how the Americans had achieved such comprehensive excellence could provide insights applicable to German fighter development, assuming Germany survived long enough to benefit from such knowledge. A team of specialists was assembled at Rechlin in autumn 1944 to conduct what they termed reverse engineering philosophy analysis of the Mustang. This was not traditional reverse engineering aimed at copying specific components, but rather an attempt to understand the thinking and priorities that had guided American designers. The team was led by Oberst Dietrich Schwenker, a pre-war aeronautical engineer who had transitioned to military service, and included some of Germany's most brilliant technical minds. Their analysis, compiled over several months and documented in reports that survived the war, provides fascinating insights into how German engineers viewed American design philosophy. Schwenker's team identified several fundamental differences between American and German approaches to fighter design that explained the Mustang's superiority. The first and perhaps most significant difference was in design priorities. German fighters were typically optimized for specific performance maximums: maximum speed, maximum climb rate, maximum altitude. This approach produced aircraft that excelled in particular flight regimes, but had significant limitations outside those regimes. The Bf-109, for example, was optimized for high-altitude interception and had excellent climb performance and good speed at altitude. However, it had poor low-altitude performance, difficult ground handling, and inadequate range. The Bf-190 was optimized for low-altitude performance and had excellent speed and maneuverability near the ground, but it struggled at higher altitudes where bomber interceptions occurred. The Mustang, by contrast, was optimized for balanced performance across all flight regimes. It did not have the absolute best climb rate, or the absolute highest speed, or the absolute best turn rate, but it was very good at everything. This jack-of-all-trades approach, which German engineers had historically viewed as inferior to specialized optimization, proved far more effective in actual combat where conditions constantly varied. The Mustang pilot could fight effectively, regardless of altitude, speed, or tactical situation. The German pilot had to maneuver to bring combat into his aircraft's optimal regime, giving the initiative to the enemy. The second major difference was in the emphasis on pilot workload and ergonomics. German fighters were designed with the assumption that pilots would be highly trained specialists capable of managing difficult aircraft. Cockpit layouts were often cramped and illogical. Visibility was frequently poor. Control forces were heavy. Landing characteristics were unforgiving. These were not seen as flaws, but rather as acceptable compromises in pursuit of maximum performance. The Mustang design philosophy was radically different. Reduce pilot workload to allow maximum focus on fighting the enemy. The cockpit was spacious and well laid out. Visibility was excellent. Controls were light and responsive. The aircraft was stable and forgiving. Takeoff and landing were straightforward. This philosophy recognized a truth that German designers had missed. Combat effectiveness is not just about aircraft performance, but about the complete human-machine system. A pilot who is comfortable, can see clearly, and does not have to fight his aircraft to make it do what he wants, is far more effective in combat than a pilot flying, a theoretically superior aircraft that requires constant attention to manage. Schwenker's team calculated that the ergonomic advantages of the Mustang effectively gave American pilots an additional 10 to 15% combat effectiveness compared to German pilots in equivalent tactical situations. The third critical difference was in manufacturing philosophy and its impact on design. German aircraft were designed to be built by highly skilled craftsmen using traditional manufacturing methods. Components were often hand-fitted, tolerances were loose, and each aircraft was slightly different from the next. This approach had worked well in peacetime and in the early war years when production rates were relatively low and skilled workers were available. By 1944, with Allied bombing disrupting production and skilled workers increasingly scarce, the system was breaking down. Aircraft quality was declining, production rates were inadequate, and maintenance was becoming increasingly difficult. The Mustang was designed from the beginning for mass production, using interchangeable parts and semi-skilled labor. Every component was precisely specified with tight tolerances. Parts could be manufactured at different facilities and assembled into complete aircraft with minimal fitting. This approach required more sophisticated tooling and more careful design work up front, but it enabled production rates that Germany could not match. North American aviation was producing Mustangs at a rate exceeding 300 per month by mid-1944. The entire German fighter industry was producing approximately 1,000 fighters of all types per month, and this production was achieved only through heroic efforts and increasingly desperate measures. The American production advantage was not simply a matter of having more factories, but of having a superior manufacturing philosophy built into the aircraft design itself. The analysis team also examined the Mustang's development history and identified another significant difference: the American approach to iterative improvement based on operational feedback. The P-51 had gone through multiple versions, each incorporating lessons from combat experience. The original P-51, with its Allison engine, had good low-altitude performance, but poor high-altitude capability. Rather than abandoning the design, American engineers had simply replaced the engine with the superior Merlin, transforming the aircraft into an excellent high-altitude fighter. The P-51B incorporated further improvements in systems and equipment. The P-51D added the bubble canopy for better visibility and other refinements. Each version was better than the last, with improvements implemented rapidly based on feedback from operational squadrons. This cycle of continuous improvement was largely absent from German fighter development. New designs were developed to specific requirements, put into production, and then modified only reluctantly if problems emerged. The feedback loop from operational units to designers was slow and often ignored. Changes were seen as admissions of initial design failure rather than natural evolution toward optimum configuration. The result was that German fighters entered service with flaws that remained uncorrected for months or years, while American fighters were continuously refined to address any deficiencies that emerged in combat. Schwenker's final report, submitted to the Reich Air Ministry in January 1945, concluded with recommendations that were prescient but came far too late to influence the war's outcome. He recommended that future German fighter development should prioritize balanced performance over specialized excellence, should emphasize reducing pilot workload through better ergonomics and easier handling, and should incorporate design for manufacturing principles that enabled mass production with interchangeable parts. He also recommended establishing rapid feedback mechanisms between operational units and design teams to enable quick incorporation of combat lessons. These recommendations, had they been implemented in 1940 or 1941, might have significantly altered the course of the air war. By January 1945, with Germany's collapse only months away, they were academic exercises with no practical impact. The insights gained from studying the captured Mustang would influence post-war fighter development in many countries, but they came too late to help the Luftwaffe that had generated them. Beyond the technical analysis, the captured Mustang program had profound effects on Luftwaffe morale and combat effectiveness. As word spread through operational fighter units that their own test pilots had concluded the American fighter was superior to German equipment, the psychological impact was devastating. Pilots who had been told they flew the world's best. Fighters now knew this was false. Combat loss rates, already catastrophic by late 1944, climbed even higher as German pilot confidence eroded. Experienced aces who had survived years of combat began refusing to fly, not from cowardice, but from the rational calculation that flying had become suicide with no reasonable chance of affecting the war's outcome. Newer pilots, inadequately trained due to fuel shortages and sent into combat with as little as 20 hours in type, were slaughtered in encounters with experienced American pilots flying superior aircraft. The average life expectancy of a new Luftwaffe fighter pilot in early 1945 was less than 10 combat missions. Many did not survive their first encounter with Mustangs. The Mustang's dominance was not absolute or universal. Individual German pilots with superior tactical position could still shoot down Mustangs, and several Luftwaffe aces achieved significant victory totals against American fighters. Hauptmann Heinz Baer, for example, claimed over 30 Allied fighters destroyed in the last year of the war, despite acknowledging the Mustang's superiority. Major Gerhard Barkhorn, the second highest scoring ace of all time with 300 victories, survived the war despite flying extensively against Mustang-equipped American formations. These successes, however, were exceptions that proved the rule. They required exceptional skill, favorable tactical circumstances, and usually numerical superiority to overcome the Mustang's inherent advantages. For average or above-average pilots in equal circumstances, combat against Mustangs was a losing proposition. The statistical evidence was overwhelming. By early 1945, American fighter pilots were achieving kill ratios of 5-to-1 or higher against Luftwaffe fighters. This was not due to American pilots being dramatically more skilled than German pilots, but rather to American pilots flying better aircraft with better support systems and better training. The captured Mustang program also influenced German jet fighter development, though again too late to affect the war's outcome. Engineers studying the Mustang recognized that its advantages stemmed largely from systemic design excellence rather than any single revolutionary technology. This suggested that German jet fighters, like the Me-262, needed similar attention to handling qualities, pilot ergonomics, and operational practicality. Late-war jet fighter projects incorporated some of these lessons, with improved cockpit layouts, better visibility, and more attention to ease of maintenance. The Heinkel He-162 Volksjäger, designed as a simple jet fighter that could be mass-produced quickly, reflected some Mustang-inspired thinking about manufacturing efficiency, though it arrived too late and in too few numbers to matter. Post-war German aviation, both in West Germany and East Germany, would heavily incorporate lessons learned from studying captured American aircraft during the war. The captured Mustang at Rechlin became, in effect, a teacher whose lessons would influence fighter design for decades after the war ended. Some Luftwaffe pilots who flew the captured Mustang survived the war and later wrote or spoke about the experience. Their testimonies provide poignant insights into the psychological impact of recognizing they had been fighting with inferior equipment. Hans-Werner Lerche survived the war and later immigrated to the United States, where he worked as an aerospace engineer and test pilot. In interviews conducted in the 1970s and 80s, he spoke candidly about flying the captured Mustang and what it had meant to him at the time. He described the aircraft with genuine admiration, calling it the finest piston engine fighter ever built, and noting that even 40 years after the war, he considered it a privilege to have flown it. But he also described the psychological burden of knowing that German pilots were dying in inferior aircraft while their leaders denied reality. He spoke of the anger he felt at the Luftwaffe High Command for sacrificing pilots through incompetence and ideological blindness. The Mustang had shown him what was possible when engineering excellence was applied systematically to fighter design, and by comparison, German fighters seemed crude and compromised. This realization had destroyed his faith in German military leadership long before the war ended. Johannes Steinhoff, who had flown the captured Mustang in summer 1944 and later commanded jet fighter units in the war's final months, spoke after the war about how the experience had affected his thinking. He described flying the Mustang as a revelation that changed his understanding of air combat. Before flying it, he had attributed German losses to superior American numbers and Allied air superiority. After flying it, he understood that the Americans also had superior equipment, superior training systems, and superior operational concepts. The Mustang was not just a good fighter aircraft. It was the product of a military-industrial system that worked more effectively than Germany's at every level, from initial design through production to operational deployment. This systemic superiority, Steinhoff concluded, meant that Germany could not win the air war regardless of pilot skill or tactical innovation. The outcome was determined by fundamentals of industrial capacity and organizational effectiveness that Germany could not match. The captured Mustang had made this truth impossible to deny. Other pilots who flew the captured aircraft spoke of similar realizations. Heinz Nock, whose diary provided one of the most detailed personal accounts of a Luftwaffe fighter pilot's war, wrote that flying the Mustang had been simultaneously exhilarating and depressing. Exhilarating because it was genuinely superb aircraft that was a joy to fly. Depressing because it made clear that German pilots were being sent into combat with equipment that could not compete on equal terms. Nock survived the war but carried psychological scars from his experiences, including the knowledge that many of his friends and comrades had died at least partly because they had been given inferior tools with which to fight. The Mustang represented what might have been if German leadership had prioritized practicality over ideology and systematic excellence over propaganda. The physical evidence of the captured Mustang program largely disappeared in the final chaotic months of the war. As Soviet forces advanced from the east and Allied forces from the west, Rechlin was hastily evacuated in April 1945. Most captured Allied aircraft were destroyed to prevent their recapture. Documents and technical reports were evacuated westward, with many eventually falling into American and British hands after Germany's surrender. The captured Mustang that Lerche and others had flown so extensively was reportedly destroyed by German personnel before Rechlin was overrun, though some accounts suggest it may have been captured by Soviet forces and transported to the Soviet Union for evaluation. If so, it would have provided Soviet engineers with insights similar to those gained by their German counterparts, influencing post-war Soviet fighter development. The reports and analyses generated by the program survived in various archives and have been extensively studied by aviation historians seeking to understand how the Luftwaffe assessed Allied aircraft capabilities. The legacy of Luftwaffe pilots flying captured Mustangs extends far beyond the immediate wartime context. The program demonstrated several truths about air combat and fighter aircraft design that remain relevant today. First, that balanced excellence across all performance parameters is more valuable in combat than specialized superiority in any single parameter. Modern fighter aircraft, from the F-15 to the F-22, reflect this lesson with their emphasis on doing everything well rather than any one thing superbly. Second, that reducing pilot workload through superior ergonomics and handling qualities is as important as raw performance in determining combat effectiveness. Modern fighters feature highly automated systems, excellent visibility, and intuitive controls specifically to reduce pilot workload and allow focus on tactical decision-making. Third, that manufacturing considerations must be integrated into the design process from the beginning rather than treated as secondary concerns. Modern aircraft are designed with supportability and maintainability as primary requirements, recognizing that operational availability is as important as theoretical performance. Fourth, that rapid iterative improvement based on operational feedback is essential for maintaining combat effectiveness as conditions evolve. Modern fighter programs feature continuous upgrade spirals that keep aircraft relevant throughout their service lives. All of these principles were evident in the Mustang's design and were identified by German engineers studying the captured aircraft, though too late to benefit the Luftwaffe. The human dimension of this story remains its most powerful element. Young German pilots, many barely out of their teens, climbed into inferior aircraft and flew into combat against better-equipped opponents because they believed in their cause and trusted their leaders' assurances about German technological superiority. The captured Mustang shattered those assurances, revealing that their leaders had either been mistaken or deliberately lying about equipment quality. This betrayal of trust cost lives and destroyed faith in military and political leadership. For the pilots who survived and later reflected on their experiences, the knowledge that they had fought with inadequate tools while their leaders denied reality was a source of lasting bitterness. The Mustang became a symbol not just of American industrial and technological superiority, but of German leadership failure and the human cost of that failure. Hans-Werner Lerche's first flight in the captured Mustang was more than a test pilot's professional evaluation of enemy equipment. It was a moment of profound disillusionment that marked the beginning of the end for the Luftwaffe's fighting spirit and effectiveness. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.